All right, so the last thing we're going to do before your test, which is going to be on Thursday, is spheres. So we're going to talk today about the volume and the surface area of spheres. Why do you think it is that we separate those and don't do them with the volume and surface area of other things?
Because there's no base.
There's no base, right? So we can't use the same formula that we use every time. There is no base. So there's just two new formulas that we will use to figure out surface area and volume. They're not really any more complicated than any of the other ones we use. By the end of this, there are probably 20 formulas that you're going to have on the formula sheet. So again, this test is not just about can you plug stuff in and make it work. It's about can you critically think your way to plugging the right stuff in and making it work. Like for number 5, for example, if you did 100, how come that didn't work?
Because it's a slant.
It's the slant height. How do you know it's the slant height and not the height? Because it's on the slanted line. Okay, so when do you use the slant height? When you're trying to figure out the surface area instead of the volume. Okay, volume. Good. And then for cones and pyramids, we find the volume by using base area times height and then doing what with it?
Divide by 3.
Why do we divide by 3?
Because it's 3 dimensions.
Oh. If that helps you remember it, fine, but the reason we divide by 3 is because it's smaller than if it were just constant all the way up, then it would be a what?
Cylinder.
Cylinder or prism, right? Either a cylinder or a prism, but these are not constant all the way up. What happens to a pyramid and a cone as you move up? It gets smaller and smaller. So the 1/3 accounts for the fact that you're basically hacking off the sides of a prism or a cylinder.
Since we're going to have the formulas.
Yeah, you'll have all the formulas. Yes, you will have them all, but again, it doesn't help that much if you don't know like what big B means. That's not going to help you that much. Okay? But you will have all the formulas including the area one. So like for number 1, you wouldn't have to know 1/2 Apophis times perimeter. You would have the formula for that also. Okay? All right. So just to go through a couple parts of spheres, they still have a radius just like a circle does. The difference is the radius goes from the center of the sphere. So if you're picturing like a basketball, this radius, the center is in the middle of the basketball, and then the radius goes to the outside of the ball. A hemisphere is a what?
Half.
It's a half of it. It's just a half of it. Just like we have 2 hemispheres on the globe, we live in the northern hemisphere, and then there's the southern hemisphere. That's half of the globe, so that hemisphere is that shaded area. What do you think a great circle is based on that picture? What do you think a great circle is? It's the circumference. Where is the great circle? It's right in the middle. So that means it's the biggest it could possibly be, right? Because if you have a ball, the widest a ball can possibly be would be around the middle of it, right? So that's called the great circle. The volume of a sphere with a radius of r, the equation for volume is 4/3 pi times r cubed. So the volume of a sphere, your only measure that you need is what?
Your R.
R. All you need is your radius. All right, so if you know your radius, then you can plug that into this formula and figure it out. Is 4/3 bigger than 1 or smaller than 1?
Smaller.
Bigger than 1. 4/3 is bigger than 1. If I have a pizza of 3 slices and I eat 4, that means I stole a piece from somebody else, right? So 4/3 is bigger than 1. Pi, again, I'm going to always leave it in terms of pi. You can do what you want. If you want to multiply it times 3.14, that's fine. But I'm going to always leave it in terms of pi, which means typically I'll put my pi where? At the end. That doesn't mean you can forget it. All right, I see people doing that a lot. When should you have pi? What shapes? Circles, spheres, cylinders, cones. Good. Any of those, you should have a pi at the end. Okay, unless you're just figuring out the radius. All right, so the volume is 4/3 pi r to the 3rd, which means if you're using your calculator, typically you want to be in what mode?
Classic.
Classic doesn't give you the fraction. If you're in math print mode, it will give you the n/d, will give you the 2 little boxes. So if you want to use that n/d, you want to be in math print mode. If you don't care, if you're in classic mode, then just put it in parentheses and do 4 divided by 3. That's the same thing. Okay, so whatever you prefer. I prefer to be in math print mode because I think it's easier to type the fractions into the boxes. Okay, so how would I find the volume of this first sphere on top? And again, we're starting pretty basic. This should be a pretty simple one.
So 4/3, 4 pi. Wait, do you want us to just put the pi?
I'm going to put the pi at the end. I think it's easier to put the numbers near each other.
9 square root of 3.
Not square root of 3.
Cubed.
Cubed. Good.
Yeah.
9 cubed cubed times
Pi.
pi. Okay, how do you do 9 cubed on your calculator? You can either do 9 times 9 times 9, or
Put the little thing in.
what is the little thing?
The little arrow.
It looks like an up arrow. It's called a caret.
Yeah.
All right. So, yep. It's like when you're inserting something in an English paper. If you forgot to write something, you put a little arrow, you know, and you write what you want to plug in there. So it is above the x squared. So hit 9 and then caret and then 3, and it'll give you 9 to the third power, which is what?
972. Oh, I did the whole thing.
Oh, okay. It is what? 729. So that should give you 729. So volume equals 4/3 times 729 times pi. And again, then I'm just going to take my answer and multiply it times 4/3. So if you're in math prep mode, it'll give you the little box. And your answer then I'm going to end up being what?
972.
Not just 972.
Pi.
Good.
Pi.
972 pi. Okay? And it should be bigger than your 9 cubed because 4/3 is bigger than 1. Melanie? We just did last week. I mean, you weren't here.
Oh,
You guys worked and you were,
Next Thursday.
I think, in the morning though. Yeah, but we have like a morning class and then the rest of the day. Okay. All right. What about B?
Yes. About.
What?
You would just plug it in.
What are we trying to figure out in B? This is the picture for C, so ignore that.
Diameter.
E.
So would you multiply by the opposite?
Oh.
Well, I know the volume and I'm looking for the diameter, but what's the volume equation again?
V. 4/3 pi
R.
by R cubed.
Okay. And I know V is what?
E is volume.
Yeah, but what in this case V is
1/2.
92.
Never mind.
972 pi.
It's 18.
Okay.
What?
What?
Relax. I understand we just did that, so you can see that. Or however, let's go through how to do it if you did not just do a problem where the answer was the same. Okay, so what would you do here? Obviously we can't find diameter right away, but if we find the radius, what does that do?
You get the-
Yeah, it gives you half, so then you can find the diameter by doubling it. All right, I want to isolate R. Well, if I have pi on both sides, what can I do? Get rid of the pi. So now we've just got 972 equals 4/3 R to the third. I want to get rid of this 4/3. How do you get rid of a 4/3? Either divide by 4/3 or multiply by 3/4. Multiply by the reciprocal. So I multiply both sides by the reciprocal. So times 3/4 times 3/4. What happens here? Those are gone because that's the whole reason for doing it, right? So we have R to the third equals, and then this should give us 729.
Yeah.
Yeah? Okay, 729. All right, what do you do from here? Say what you were going to say. Okay, you want to take the square root, right? Because you want to get rid of an exponent. Unfortunately, the exponent here is not a 2, it's a 3. So we don't take the square root, we take the, does anyone know what it's called?
The cubed.
Cubed root. Exactly, that's called the cubed root. Because 3 is cubed, it's called the cubed root. So, on your calculators, to show you how to do that, see the caret button that we just used?
Yes.
See the green right above it?
Yes.
How it says, like, x root?
Mm-hmm.
Okay, so type a 3, and then hit second x root. And see how it makes the 3 tiny?
3E.
3, just 3.
Oh,
And then hit second and the caret button.
Nothing.
okay, so
Should be smaller and outside of a
Is it
root.
because I'm in math? Oh, okay.
Maybe.
Sorry.
And then type in 729, tell me what you got.
9.
Yep.
9.
where are you supposed to be?
I think it's easier in macro mode, but you should be able to do it in class. 729. All right. So we ended up with 9, which is our radius, and then our diameter is what? Okay, so we took the what root? Cubed root. What if it were a 4? fourth root. What if it were 9?
9.
You can take the 9th root. You're basically saying what number times itself 3 times gives me 729. So in this case, 9 times 9 is 81, times 9 is 729. Okay? So when you're taking the cubed root or the third root, that's how you do it on your calculator. You will need to do that to find the radius in any of these. Because again, square roots cancel out of 2, cubed roots will cancel out of 3. Alright, and then last but not least, what's the difference between this example and the ones that we've done so far?
That's half.
It's a hemisphere, so find the volume and then do what with it? Divided by 2. Okay, so volume is 4/3 pi r to the third. What's r here?
4.
4 to the third pi. And then this whole thing I'm going to divide it by 2. Alright, so 4 times 4 is?
16.
Times 4 is, that's right, 64. So 4/3 times 64 pi divided by 2. So go ahead and do that on your calculators or do anywhere in your head.
I don't know if it feels,
It's a fraction.
128 over 3.
128 over 3 pi. Perfect. 128 over 3 pi. Alright, so again, I'm all for you guys doing math out on paper, that's fine. But especially when you're working in volume where the numbers are getting pretty large, I think it's just quicker to do it on a calculator. But again, you can do whatever your preference is. Okay, go to these 4. Keep in mind number 4 is a hemisphere, not a sphere. Alright, so then the last thing we're going to talk about is surface area of a sphere. And unlike surface area of every other shape, which I actually think is a lot harder than the volume, I think surface area of a sphere is just as easy as volume because the equation is pretty simple. So the surface area of a sphere is just 4 pi r squared. Alright, so 4 times pi r squared. Where does the pi r squared come from? Area of the circle. Okay, and so the surface area of a sphere turns out to be 4 of the great circles. So you know the circle in the middle? It's like 4 of the great circles around the outside of a sphere. Alright, so you do 4 times the area of that great circle, which is pi r squared. So if the diameter is 10, how would you do the surface area of that sphere?
4 pi 5 squared.
Good. What's 5 squared?
25.
25 times 4? 100. So your surface area would be 100 pi.
I don't know what I said, but was it right?
Yeah, it was right. Yep. So surface area is 100 pi and then feet squared because we're back to surface area. Go ahead.
She got 5 because it's half.
Yep. If the diameter is 10, then the radius is 5. All right. What about B? B is much more similar to the type of problems you'll actually see. You're not going to see a lot of A. A is super simple. A is very easy. It's just plug and chug. That's not what I'm testing for you guys. So let's look at B. What's B asking you to do? It's asking you to find the volume. So we're going to have to at some point use this equation. And then it gives us the what? Surface area. So we're also going to have to use this equation. Which one do we use first? Why, Bianca?
Because it gives you like the information you need.
To figure out the, yes, because what do you need to figure out the volume? Not the area, but what measurement do you need to figure out volume? Radius, and you don't know radius, but you can figure it out using the surface area. So the surface area is 144 pi. So what can I do with my pi's?
Just round them out.
Those go away, and then I divide by what?
4.
4. So I'm essentially dividing by 4 pi. All right, what's 144 divided by 4? 36? 36 and 36 equals r squared. So then what would the radius be? 6. Why is it 6? Square root of 36 is 6. So radius is 6, and then what do?
You
Plug it back in. So 4/3 times 6 to the third times pi. So I'm going to end up doing 36 times 6 and then multiplying that by 4/3, and then that should give me my answer. what is it?
288.
288 what?
Pi.
288 pi, and then meters to the cube. Why is that one cubed?
Because volume.
Alright, that one's volume. Okay? I'm going to recommend every time that you write out all the equations you need. Okay, and then the last one that we're going to look at is the surface area of a sphere with a great circle that has an area of 4 pi. So the area of the great circle, which is just this circle in here, is 4 pi. So what does that let us figure out? That's going to let us figure out the radius, because what's the equation for area of a circle? Squared. So if 4 pi equals pi r squared, what happens to the pi's? They cross out. So 4 equals r squared. So then what's r? 2. Okay, so now we've got the radius, and we plug that into which equation?
No, it's not.
Yeah, because we're looking for surface area, so 4 pi r squared. So then s equals 4 times pi times 2 squared, which is 16 pi. 2 squared is 4, 4 times 4 is 16, and my units end up being inches squared. Could we have shortcutted to that?
Yes.
Yes.
How?
Not the radius.
We didn't really need to do this because we knew pi r squared was equal to what? 4 pi. So we could have just taken out the pi r squared here and plugged in what? 4 pi, and then it would just be 4 times 4 pi. Okay, so if you have the area of the great circle, that can plug in here too.
What? Say one more time.
Okay, so we know that area is pi r squared, right? And that shows up right here in this equation. So if I'm telling you that area is equal to 4 pi, then you can take out pi r squared and plug in 4 pi right here. And your answer would then just be surface area equals 4 times 4 pi, which still gives us 16 pi. Okay, so basically if you have the great area, just multiply it times 4. Because remember, the great area is the circle in the middle, and 4 of those put together make the surface area of the sphere. Okay? Or do it this way, because honestly, it didn't take us that much longer. And the first time I did it, I didn't think about doing it that way, and then I was like, oh, that's dumb, you could shortcut this. Okay? So it's okay if you don't think of a shortcut. It still didn't really take us that long. I know you guys look at, like, that looks like a lot of work, right? But, good, Angel, thanks. That might be the first time you said that. But that looks like there's a lot of writing that we did, but it's not really that much work, especially, like, you guys make mental leaps really quickly, so. Okay, and then the last thing is changing dimensions. So again, whenever you're doing changing dimension problems, your answer shouldn't really just be a number. What should it be? Kind of a measure, but like, what are you looking for? If I say, how did the dimensions change? Give me an example of what your answer might look like. Times 4, times 12. So there will be a number, but it will also include an operator, either times or divided, usually. When is it divided? If the shape is getting smaller. So if it's a reduction, but if it's an enlargement, then the number should be multiplied. Yep, okay. So the radius of the sphere is tripled. Describe the effect on the volume. So we need to do the original volume and the new volume. And it says the radius is tripled. So what's the radius originally? So then it would be 4/3 times 3 to the third times pi. And then our new volume would be 4/3 times what to the third? 9 to the third times pi. All right, so these two rows, this first row and second row, do this first one with 3. And these two rows do the second one with 9. And I can't stop here because I haven't figured out the change in dimensions. So how do you do that part?
You divide by 36.
Divide 972 by
36.
36. And your answer should be what though? Times or divided. Why is it times 27? It's getting bigger. So how come you use division to figure it out, but the answer is times?
You have to see like this.
What's the difference?
Division lets you figure out how many times this fits into this, but that's how many times it's being multiplied. Rather than being like, okay, let's see, maybe it's 36 times 5. Nope, that didn't work. 36 times 8. That would be annoying, right? Guessing checking your way to 27 would be an annoying way to do it. So we divide to figure out how many times it goes in, and then your answer is times 27. Okay? So when you're doing effects of changing dimension, make sure that you're putting the actual change, not just the numbers. Okay, go do these 3 before you go up there though. For number 3, it's a composite figure. What is the composite figure here? It's a cone and a hemisphere. So it's a cone and a hemisphere. So you've got to find the volume of the sphere, and then do what with it? Cut it in half, and then find the volume of the cone. So maybe buddy up with a partner on that one. One of you find the cone, one of you find the sphere. Okay, go.